So we've solved systems by graphing, we've solved by substitution, we've solved by elimination. Now, there's actually a fourth way that not a ton of people know about, but it's kind of a neat trick, so we're going to go through it. It's called Cramer's rule. And in order to do Cramer's rule, we have to know what a determinant is. Well, the determinant is a number found by multiplying and subtracting other numbers. Okay, and so the four numbers in a determinant are set up in a square, 2 rows and 2 columns. So here's the determinant of 3, 5, 2, 7. And I'll show you how that gets set up in just a minute with our systems. But for now, know a determinant is a 2 by 2 looking thing like this. And what we do is, to find the value is, the first thing we do is multiply diagonally. We always start with the top left and multiply to the bottom right and get that number, 21. Okay, and then to get the next number, we take the bottom right and multiply, or the bottom left and multiply to the top right, and we get another number. Okay, and then what we do with those two numbers is subtract them. And the order matters. That's important. The order matters. So what I always do is I always start with the top left. Start with the top left, multiply diagonally. So 3 times 7, 21. And then take the bottom left and go diagonally. So 2 times 5, and we'll subtract 10 from 21. So that order does matter. We have to do 21 minus 10 to get the determinant value of 11 in this case. We can't go the other way. Okay, so you got to know that rule. Start with the top left. Start with the top left. So the value of that determinant is 11. Okay, and we're going to use the letter D for determinant. Okay, you'll see that when we get there. So let's just do one of these. Let's just to get some practice, but just be careful with your signs. So let's grab a tricky one. Let's go down to this bottom left one right here. Right, so like I said, start with the top left. So I go -4 times -3. So I'm going to actually write this out. So -4 times -3, which is positive 12. And then we subtract. So I like to put my minus sign right away. Well, -1 times 2. So -1 times 2, which is -2. Oh, so I have 12 minus -2, which is really plus. So this value of the determinant would be 14. So like I said, those signs are tricky, right? Remember, because we're subtracting, plus we had a negative number, so we subtracted a -2, so I really had to add 2. So just be careful with things like that. All right, so Cramer's rule works best when the equations are in standard form. So that means the x and the y terms are on the same side of the equation. So we'll use the system to help us write different determinants. So we're actually going to write 3 different determinants. We're going to write one called D, we're going to write one called dx, and we're going to write one called dy. And I'll explain how all 3 of those works. But we need all 3. All right, so let's grab a system. So if we notice, I have an equation with 2 variables, so I need a second equation with those same 2 variables to solve. We call that a system of equations. And if you notice, they're in standard form, right? I have ax plus by equals c. They need to be in that form, so that's good. Got that taken care of. So first thing is, let's write our first determinant. This one over here, d. Well, to write our determinant, we just grab the coefficients on the variable. So 3, 2, 2, -3. So I'm going to go 3, 2, 2, -3. For our other determinants, let's go ahead and solve this right away. So we just get this down. So to find d, remember we start with the top left and multiply to the bottom right diagonally. So 3 times -3 is -9. And then we go minus 2 times 2, which is 4. So d is going to equal 5. So I got that. So I'm going to box it here so I know. Okay, to set up dx, what we need to do is we're going to replace the x's, so these guys, with the solution. So the solutions are now going to replace the x's, hence the dx. So instead of writing 3 and 2 for the x spots, I'm going to write 17 and 7. And then I still keep my y's the same. So 2 and -3 like that. Okay, so that gets straight. So for dx, we replace the sums, the solutions over there, in for the x's. And then we follow our same rule. So I multiply diagonally, so 17 times -3 It gives me negative 51, and minus 7 times 2, which is 14. So negative 51. So this is going to be dx, right? Negative 51 minus 14 gives me negative 65. So I'll box that there. And then lastly, we have dy. So guess what gets replaced? Well, let's just quick write. So these are my x's, these are my y's. So now these are the answers, right? And these are my y's. And now I'm going to have my x's, and guess what we're going to replace? We're going to replace the y's with the answers. So we take the 17 and the 7, and they go in for the y's now, hence the dy. So I'll put 17 and 7 in there. And then on the left side, we have our x's, so the 3 and the 2. And let's go ahead and solve this determinant. So we go 3 times 7, which is 21, minus 2 times 17, which is 34. So dy is going to equal negative 13, right? Because I can add the opposite right there. Okay, so well, how does that help me? Well, down here, if you notice, we have this. X equals the determinant of x divided by the determinant. So to solve for x, all we do is we take the determinant of x, which was what? Negative 65. And we divide by the determinant, which is 5. So x would equal negative 13. And then how do you find y? The same way, except you use the determinant of y, which is 13. So y is going to equal 13 divided by, what was the negative 13, my fault. Divided by the determinant, which we said was 5. And I could just leave it as a fraction. So y equals negative 13 fifths. And then if you look down here in the corner, it says, remember to write your answer as an ordered pair. So let's do one more of these. What about something like this? What do we notice right off the bat? All my equations, they're not in standard form. So I need these guys with the x and the y on the same side. So look up top. How can I get the x and the y on the same side? Well, the y's on the left side. Could I get the x over there? Yeah, let's subtract the 3x over to that side. So how would I rewrite that? Negative 3x, right? The x comes first, and then it's a positive y, so plus y, equals, well then, negative 5. And then I got to do the same thing to the second equation, get the x and y on the same side. So the x is on the left side, let's get the y over there. So minus 3y, minus 3y. So that would become what? 2x minus 3y equals 1. And you notice how I have the x's lined up with each other and the y's lined up with each other, and then the answers on the other side. That's what we want. We want them lined up just like that. Because when I write my determinant, my very first one, I got to take the coefficients of x to be on the left, so negative 3 and 2, and the coefficients on y to be on the right. Well, negative 3. What's up top? There's an imaginary 1 in front of that y, right? So 1. Let's just quick write all my determinants out. That might be a good idea just so you don't make any mistakes. So for dx, remember, we replace the x values with the answer. So this is going to be negative 5, 1. And I put my y's in still, so 1, negative 3. And then just the opposite for dy. So my solutions go in for y's. And I put my x's back in on the left side. There we go. Now we go ahead and find all of our determinants. So negative 3 times negative 3 is 9, minus 2 times 1. So d equals 7. And then we go for negative 5 times negative 3, which is 15. And minus 1 times 1, which is 1. So dx equals 14. And lastly, negative 3 times 1 is negative 3. And 2 times negative 5. Remember, it's minus first, so it's negative 3 minus. And 2 times negative 5 is negative 10. So be careful with that sign. So that means dy is going to equal, well, negative 3 plus 10, which is 7. And to find x, remember we take dx divided by the d, right? The dx divided by the determinant. So we take 14 divided by 7, which is 2. So x equals 2. And then for the y, we take dy divided by the d. So y would be 7 divided by 7, which is 1. So y equals 1. And do I leave my answers like that? Nope, we write them as an ordered pair. So we have 2 for the x, 1 for the y. There is my final solution right there. Okay, so Cramer's rule is kind of neat, kind of saves you some time, depending on what your solution or what your system looks like. Remember, we can always graph, we can always use elimination, substitution, but let's get some practice using Cramer's rule now.